Okay, let's keep that beat going with this next part of the test. The inscribed angle of 72 degrees would mean that on the arc it would have to be twice as big. Remember, I was also drawing pictures of mouths that were chewing on the angles. So this little angle right here is being 72. This acute angle would give me 144 degrees on the circle. Now a circle has 360 degrees total, and if we have 144 taken up by that white part of the arc, that means that this yellow part would have to be worth 216 degrees. And then it's back taking a look at the picture. We're looking for angle D. We want to explain why angle D would be worth 108. Well, that angle, or that mouth there, is chewing on the yellow part of the circle. So that angle right here being inscribed would have to be half as much as 216, so 108 degrees. And that would be a good explanation. It says to explain why, and since it says explain, this is not enough right here. You're going to have to provide some words. So write a sentence that explains what I just did to get full credit. Question number 2 is going through a sequence of transformations, a reflection followed by a rotation for each of those points. And you don't have to analyze the picture all too much. It says that there was a sequence of transformations, and those transformations were rigid. So explaining why means you need to provide at least one sentence, and this would be maybe the quickest way and the most perfect way to explain it, is that reflections and rotations are rigid. And rigid motions keep images congruent. That would be enough to get the question right. If you wanted to actually throw a little icing on the top of it, you could just say that the triangles are congruent because of side-side-side congruence. That every side in one triangle has a matching side in the other. And you can even mark up the picture to show which pieces match up with which pieces. Alright, here we are with question number 3, where we're completing a proof that's done on a coordinate grid or coordinate axis. Whenever they ask you to do a proof, it doesn't mean you're going to do statements and reasons every single time. When you do a proof on a sheet of graph paper like this, you're going to want to figure out every single slope and every single length. If you do that, you're on your way to get full credit. And then knock it out of the park by explaining with a sentence or two what's happening in the picture. It all begins by graphing it correctly. So taking the time to double check to make sure you graph it correctly will avoid a lot of frustration. So this is what I actually seen on plenty of students' papers, is that they knew that they had to figure out the slope. So they said, oh, that's 10 down and 6 across, and maybe this is up 3 and over 5. But they just left the work like that. That's not figuring out the slope. If you do just that, that would be like ordering a pizza, and the pizza delivery person shows up and just gives you a ball full of dough, pepperoni that's not cut up, and cheese that's not even melted, and say, here, you just do it yourself. Hey, what you want to do is you actually want to mix, you want to get this thing complete. So you don't want to just do an incomplete job. You want to have a fully cooked pizza. So to do this correctly and in a very quick way, take those numbers and actually turn them into a slope. A slope is a fraction. And tell me which side you're figuring out. Make it crystal clear. The slope of TS is down 10 over 6. If you wanted to figure out the length, that could be quickly done too by just doing 10 squared plus 6 squared, square rooted. So the length would be radical 136. You could do the same thing for this side right here, but look how I'm labeling that too. The slope of SR is up 3 over 5. And if I want the length of it, again, that's lightning fast. The length would be 3 squared plus 5 squared. So we got 9 and 25, that'd be radical 34 for the length. You could do the same thing for T to R, but as it turns out for this proof, that would be unnecessary because all we're trying to determine is if this angle here is a right angle. It looks like a right angle, it looks like 90 degrees. To prove that it's a right angle, you're going to need to use the slopes to do it. And somehow the slope here and the slope here are supposed to tell you that there's a right angle. And did you notice that I did not reduce yet? When you reduce this fraction, you'll see that it becomes negative 5/3, and this slope is 3/5. And that combination right there is called a negative reciprocal. You could abbreviate negative reciprocal. And that means that if there's negative reciprocal slopes, we have perpendicular, or we have 90 degrees. And that's part of the sentence to explain things. Okay, so negative reciprocal slopes, let's write a full sentence. Negative reciprocal slopes means we have 90-degree angles. Therefore, triangle RST is a right triangle. Okay, question B. State the coordinates of point P so that it becomes a rectangle. Well, with a little thought, you could figure out that P would have to be located here. Now, how did I get that? Well, if I have to get a right angle up here for T, and this is going down 5 over 3 as its slope, I've got to go up 3 over 5 to find point P, and down 10 over 6 to get back on point R. So that's very good work if you found that point, but it's not going to get you full credit unless you state the coordinates. So point P is at the location 0, 9, and now they're asking me to continue on with another proof. Prove that the entire shape is a rectangle. Well, how I found P is exactly how I have to explain or prove that it is a rectangle. And I'll just continue to do that correctly by figuring out the slope of TP. I already know it's up 3 over 5 because that's how I planned it out. And also I know that the slope of PR is equal to negative 10 over 6, which reduces to negative 5/3. So there's really not much for me to do in part C, not a lot of heavy thinking, just to write down what's happening. We've got negative reciprocals again. So we got more negative reciprocals. So negative reciprocal slopes create 90-degree angles for each corner. Therefore, RSTP is a rectangle. And then this is an important question for me to see that you get this right on the exam. So providing slopes, providing lengths, and giving a sentence makes this question completely correct. If you found the slope and length of TR, that wouldn't be necessary, but it's not incorrect if you did. And the same thing, we didn't have to figure out these lengths, but we could have. In this case, the slopes were most important. But sometimes the lengths will be very important. Let's say we're supposed to prove that something is an isosceles triangle or not an isosceles triangle, or proving that something's a rhombus. Then you'd need the lengths to help you complete your proof. Okay, a question like number 4 is one that is only worth 2 points, but we're going to have to explain quite a bit to get there. It all begins by putting down the measurements that they gave us in the reading, that's 50, that's 115 degrees. And they're telling us that this is an isosceles triangle. They want us to explain why the segments are parallel. We don't know that they're parallel yet. We're trying to prove that they're parallel. So it would be incorrect to start using alternate interior angles and corresponding angles. Like, we don't know that that's 50 degrees yet. I mean, that's 50, so this should come out to be 50. If it does, if these do agree, then we have enough information to prove that they are parallel. The segments are parallel. So going with the information they gave us, and it says to explain again, so it means we're going to have to provide some words for it. I won't write the sentences down because that's just going to slow my explanation down, but you would have to actually write out that this angle here has to be worth 65 degrees because these two angles are linear angles. They add up to 180 degrees. Now this angle here would have to be 65 degrees also, because in this triangle right here, we've got two sides that are equal, which makes it an isosceles triangle. And if those two angles, if it's an isosceles triangle, those two are our base angles, and base angles are always equal. You would have to write that down. That makes this angle here 50 degrees, and explain why. Because in a triangle, the three angles have to add up to 180 degrees. And then the final thing that you'd have to write out is that since both of these angles ended up being 50 degrees, since the corresponding angles are equal, that makes the line segments or the lines parallel to each other. You could have done a few other things with the question. I saw a lot of students write that this was 50 degrees as well, and you could have also finished off the proof that way, or not proof, the explanation. If this is 50 in yellow, then in black it's 50 because vertical angles are equal, and now we've got alternate interior angles that are equal, which makes the lines parallel to each other. Don't be afraid to over-explain on the test, especially with the fact that you have 3 hours to do the test. Okay, question number 5 is a proof, and it's important that you don't panic on a proof like this, or any proof, but sometimes these proofs end up being very friendly in terms of how many points you can score, even if you don't know how to do the entire thing. In this question right here, there's a lot of triangles in the picture, so let's figure out what they want us to prove. They want us to prove that these triangles in yellow are congruent to each other. So in the back of my head, I'm thinking I need to use side, 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 or angle, side, angle, or angle, angle, side, or side, angle, side, but probably not hypotenuse, leg, because there aren't any right angles. So in this question, there's actually several things you can do to get full credit. In the first step there, you want to list the given information. And it can be listed as 2 separate lines of given information to begin with. But moving on to the important thing is that there's several ways to work this question out. This is one way, and probably most students would jump on the vertical angles here. So angle 1 is equal to angle 2 because vertical angles are equal. Alright, that gets us on the scoreboard. So I'm already thinking ahead that if I started the question that way, it's probably going to end with one of these 3 theorems. And another thing that I could pick on is that angle 3 is equal to angle 4, because alternate interior angles would have to be equal since we've got a parallelogram. Alternate interior angles are equal. So now I've got 2 angles, so it looks like I'm going for one of these 2 possibilities. Now I just need a side someplace, And we can do that a couple different ways, and the easiest way maybe to do is to say that AD is equal to CB. And that is because of it being a parallelogram that opposite sides are equal in a parallelogram, or opposite sides are congruent. And that finishes the proof in that many steps. The triangles would have to be congruent, and one way to do that is to say that it's true because of angle, angle, side. Okay, as mentioned before, there are other ways to complete this proof as well. Going back to just the picture alone, I accomplished it by doing angle, angle, side. You could have also finished the proof by doing angle, side, angle. You could have said that these segments are congruent because in a parallelogram the diagonals bisect each other. You could have also done the question with side, side, side. We have the opposite sides equal. We have that the diagonals bisect each other here and here. We also have that the diagonals bisect each other here and here. This question could have also been done with angle, side, angle. You could say that these angles are equal because of alternate interior angles. And I guess there's even another way to work this question out as well. You could have also used that the diagonals bisect each other, making those equal and these equal, and then using the vertical angles here and here to do a side angle side proof. Now on the exam it's possible that there might be only one route to the answer, but there might be more than one way to work the question out, which makes the question a lot better for you to answer, but it might make you feel uncomfortable because you might think that there's too much information. So just narrow down your choices of what you need to use and keep your eyes open for the fact that there could be more than one way to work the question out. Now let's talk about scoring points. I mean, if you can dig up some vertical angles for me and maybe find some alternate interior angles that are equal, even if you fumble with the finish, you're still getting 2 out of 4 points, which would be, I'd say, a success, somewhat of a success. Another thing to notice in this this proof is that we didn't use CPCTC. Now we could have if they asked us to go on and prove something like prove that DE is equal to BE. Then we could have continued on and used CPCTC to finish things off, but that was not needed in this question. Moving on to question number 6. They're asking you to divide a segment or partition a segment on a ratio of 2 to 3. So that means we're going to need to break it down into 5 parts. And it begins by sketching it correctly. So there's point A over here and point B at 4, 0. And drawing with a straight ruler is important. Now to get from A to B, the slope can be figured out by just counting. So it's going up 1, 2, 3, 4, 5 over, I believe, 10 spaces. So just like I did on the proof earlier, label it. The slope of AB is up 5 over 10. Now we're dividing that into 5 parts. So to split up the segment, we're not going to go up 5 over 10. We're going to go up 1 over 2 again and again to break up the shape. So going up 1 over 2, up 1 over 2, and continuing that will help you see that we've taken the shape and we've taken the segment and broken it into 5 pieces. Now, where does the point get placed? Well, according to this, it says that AP compared to PB would be at a ratio of 2 to 3, which means that B won that tug of war. B is getting 3 of the pieces, and A is only getting 2 of the pieces. So if that's correct, point P would be right here. If you did all that work, it's worth 2 points. You're only getting 1 point. It says to state the coordinates, so be sure to do that. So the answer would be -2, comma, -3. And it's giving you full credit. This brings us to our last question on the test. The volumes of these 2 shapes are being compared, these 2 solids. One of them is a cone. The volume formula for that is on the formula sheet. The other one is a cylinder. And I'd say for the most part, students were very successful with this, especially the cylinder and knowing that they had to divide. They want to know how many of these actually fit into this. And, well, the only mistake that students really made, that I've seen the most popular mistake, was they used 5 for the height of the cone. And 5 is not the height of the cone. The height of the cone is this segment from here to here. And that can be easily figured out by noticing that that's a right angle, and that you could use the Pythagorean theorem to find the missing side. So we get x squared plus 9 equals 25. Subtracting 9 from both sides gives you x squared is 16. And then square rooting gives you that x is equal to 4. So that one started off with just a calculation so that we could complete the formula. And it's not uncommon on the exam for this to happen, and in real life, is using another little formula to get a measurement you can't get for some reason, or you don't have for some reason if you just have some partial information. On these volume questions, it's not uncommon to see even SOHCAHTOA being used. So our volume becomes pi times 12 for the cone, which you could make a decimal if you needed to. You could type it into the calculator, which comes out to be around 37. If you found the volume of the cylinder, the volume would be pi times the 4 squared times the height, which is 6, which gives you a total of 96 for the volume of the 96 times pi for the volume of the cylinder. Or I mean, on these ones you could write 12 times pi and 96 times pi. And again, you could type those into the calculator. We want to know how many of these go into here. That sounds like division to me. How many of the 12 pi's can go into the 96 pi? If you did it this way, the pi's would end up canceling, and it's just 96 divided by 12, which would be 8. So 8 cones fit into that one giant cylinder. Alright, keep your studying going, working really hard. Watching this video again or pausing it and replaying the parts that you missed are important. But there's still, at this time, if you're watching the video like I told you to, there's still some time in between to ask some questions to me. Come to another review class if there's still review classes being held, and ask some questions before the last day of the school year. So, well, hopefully I'll say thanks for watching, but you thank yourself for watching and paying good attention to this. And again, keep on pushing hard right to the finish line, and have a nice day.